Hello friends, in this video we will talk about the two's complement format. We will see the overflow condition and solve few problems. We won't talk about the one's complement format and sign magnitude format because we don't use them. Now in one of the previous videos we saw that the ranges for the two's complement is from minus to the power n minus 1 to plus to the power n minus 1 minus 1. Any number less than this is negative overflow, any number greater than this is positive overflow, and we can represent this many for negative and positive data. So if we take 4 bit, then we can represent minus 8 to plus 7, because if we put n is equal to 4 here, it will be minus 2 to the power 4, that is minus to the power 4 minus 1, that is 8, and here 2 to the power 3 minus 1, that is 7. Now we need to find the overflow condition in the two's complement format. For this we will take a look at these 4 examples, and then we will derive the overflow condition. Now let's see the first one. We are taking the largest number, that is plus 7 of the 4 bit here, and this is the binary representation of plus 7. So plus 7 plus 7, the sum will be 14. We can see that we cannot represent 14 in 4 bit, so there is an overflow, and this is positive overflow because the maximum is 7 here, but our result is 14 somewhere here. So this is positive overflow, and the overflow flag is 1. So in the unsigned data we have the carry flag, but in the signed data, that is two's complement, we have overflow flag. So overflow is 1 and it is positive overflow. Now let's see how we like add this number. So here 110, 1 is carry, then 111 is 10 plus 1, that is 11, 1 here, then again 1 here, then 1 2 3, so 3 is 11, we have 1 here and 1 carry, and then we have 100, that is 1, and there is no carry here, right? Similarly, if we take this minus 8, if we sum minus 8 minus 8, these are the least number in 4 bit. So this is the minus 8 minus 8 here. So let's see how we represent minus 8 in two's complement, because all these numbers are in two's complement. Here the numbers are positive, so it's same as unsigned, but here the number is negative. So in the 4 bit, the we can write 8 in here. If we like invert the bits, we will have 0 1 1 1, and then we add plus 1 here, so it would become 1 1 0 1 1 0 0 and 1. So this is how we get minus 8 in two's complement. If we add it, we will get the minus 16, and we can see the least number we can represent is minus 8, but here we have minus 8, but the output is minus 16 in the left hand side, so it is negative overflow. So overflow is 1 and it is negative overflow. The accumulator content is here 0000, and here 1110. Now if we take the 5 bit range, in the 5 bit we can represent from minus 16 to plus 15, and of course we can represent this plus 14 and minus 16 using this, because the both of this number falls in this range. Now we have this example minus 6 and plus 3. So we know that plus 3 is 0011, because no need to convert this into the two's complement. For minus 6 we have this as 6. Now if we apply the shortcut method from right to left to find the two's complement, this will be 0, this will be 1, and we invert everything after 1, so it will be 1 0 1 0. So this is how we get the minus 6. So if we add this, we get minus 3. You know that minus 3 falls in this range, so there is no overflow. So overflow is 0, no overflow. And if we add this, we have 0 1 1 1 1 0 1 carry, then again 1 here, there is no carries here. In the last example we have plus 6 and minus 3. So similarly we can like represent minus 3 here, so 0 0 1 1. So if we apply the shortcut, we will get 1 here, and then invert all the bits, uh, right to left. So 1101 is the representation. Now we'll add this plus 6 minus 3 plus 3. We know that plus 3 falls in this range, so there is no overflow. So we solve this for example in which we have overflow in these two, there is no overflow in these two, and we have positive overflow in this and negative overflow in this. Now we will see the conditions, everything that we can say that there is overflow, and we can also say that there is positive overflow or negative overflow, right? So let's talk on this. Let's make some space here. Now there's one thing. We have these like two carries here, right? So let's name these carries. Let's call this in carry to the MSB, and this is out carry to the MSB, right? So this is in carry, out carry. Similarly, this is in carry out carry, and in carry out carry. So from these examples, we can see that if both of this in and out carries are 0, so this x is nothing but 0, or both of these in and out carries are 1, then there is no overflow. But when one of in or out carry is 1, similarly here this is 0, this is 1, and this is 0, this is 1, that means if one of the in or out carry is 1 and one of the in and out carry is 0, then there is overflow, right? So if you write here in carry and out carry 0 0 0 1 1 0 and 1 1, so if there is no in and out, or there is both in and out here, in these cases there is no overflow. But when out is 1, in is 0, or in is 1, out is 0, then we have overflow. So this is the first condition, right? So if we know the in and out carries, we can derive if there is overflow or not. Now, how we can find if there is positive overflow or negative overflow? Again, from these two examples, we can see if we have inquiry as 0, then negative overflow. If we have inquiry as 1, then positive overflow. So here in carry is 0, so this is negative overflow. If in carry is 1, this is positive overflow. So based on this in and out carry, we can decide if there is overflow or no overflow. If there is overflow, it is negative overflow or positive overflow. So this is how we can find. We can see one more thing here, like if in in the cases of overflow, we have these ones and then 0, or we have this 0 and 1. But when there is no overflow, we have 0 1 0 0 1 0 1, right? So if we call the MSB of first operand x, the MSB of second as y, and the MSB of result is z here. So this one is x, this one is y, and this one is z. Similarly, if we call this x, y, and z, right? So if if both of this xy is 1 and z is 0, or if both of this xy is 0 and z is 1, then there is also overflow, right? So we can write this in an expression, right? If x is 1, y is 1, and z is 0, that is z bar, or if x is 0, that is x bar, and y is 0, that is y bar, and z is 1, then there is overflow. And now how we can find if there is negative overflow or positive overflow? So if z is 0, then this is negative overflow. So here z bar means z is 0, so this is negative overflow. If z is 1, then this is positive overflow. So this is how. So if we know the in and out carry, we can find overflow. Or if we know the like MSBs of these operands and result, we can also find the overflow. So these first and second concepts are like very important for the overflow. So a lot number of questions has been asked in GET examinations based on this topic. So understanding these things is very important. So I hope it is clear. If it is not, please rewatch this video because it is simple. As in unsigned data, if we are adding two n bit numbers, we need n plus 1 bit of storage. And in the unsigned data, we were using carry flag to store that extra bit, but in 2's complement we are using this overflow flag. So carry flag was nothing but the out carry, right? Because this is carry, this is carry. So carry flag is dependent on this out carry, but overflow flag is dependent on this in and out carry. So if one of them is 1, then only overflow, otherwise no overflow. So we understood these like two conditions for the overflow. Let's see these things. We have just written this in a text format. So we have this note that overflow flag is used in the CPU to hold the range exceeding condition of a signed data. That we know. Like in the unsigned data, the carry flag is used, but in signed, overflow flag is used. So what is the condition? If there is carry into the MSB or no carry out of the MSB, so this is in carry and this is out carry. There is in or there is out or vice versa. That is, if there is no in and there is out. So if in or no out or no in out, so if that is the case, then there is overflow. Otherwise, there is no overflow. And we saw here in that like above table in carry and out carry, if both of these 0 0 or 1 1, there is no overflow. And if it is like either of one is 1 and 0, it is like one of them is 1 and one of them is 0, then it is overflow. And this is exactly what XOR is. So the XOR of in and out carry, we can say, is overflow. So if we XOR 0 0, we get 0. If we XOR 1 1, we get 0. If we XOR this one means for these conditions there is overflow, for this condition there is no overflow. So using the XOR for in and out carry, XOR means XOR actually. So using the XOR of in and out carry, we can find if there is overflow or not. So, and we already talked about this. And if that in carry is 0, we have negative overflow. If this in carry is 1, we have positive overflow. And we saw these expressions as well, right? If x, y and z are like MSB or operand 1 2 and result, then we have this positive overflow x bar y bar z, and x y z bar is the negative overflow. So like if you want to remember this, when z is 0, that is the MSB of result is 0, then it is negative. And if the MSB of result is 1, then it is positive overflow. And of course the like if MSB of result is 0, the MSB of operand 1 and 2 should be 1 1. And if this MSB of result is 1, the MSB of operand 1 and 2 should be 0 0, then only there is overflow. So these are the conditions for the overflow. Let's solve few like questions similar to the unsigned data. This is the example 1. We have +1 and +3, so we can represent in +7 this year, 3 year and 10. So we know that the ranges is from -8 to +7 in 4 bit 2's complement. So this is +10, so this is out of range. Then it is positive overflow. And here as well, this in carry is 1, out carry is 0, that means there is overflow. And in carry is 1, that means positive overflow. And the MSB of result is 1, that also means positive overflow. So there are like various methods you can find, like you can use to find which overflow is this, positive or negative, or if there is overflow or not at all, right? Let's justify this. So in the PSW, we have this accumulator 1011, and then the flag register flag overflow is 1. We know that, right? Because we have this in carry as 1, out carry is 0, so we have overflow. But what type of overflow? So x bar y bar z is 1, because x is 0, y is 0, and z is 1, so this is positive overflow. So the answer will be this accumulator plus this overflow. So if there is positive overflow, we put 0 here. If it is negative overflow, we put 1 here. If there is no overflow, we just take the accumulator content. We don't add 0 or 1. Similar For example, the second example here, if we add 7 and minus 3, we get plus 4. We can represent plus 4 in this range. So there is no overflow. Also, we can see we have both this in and out carries and R1, and here we are not meeting that condition, that x y z bar plus x bar y bar z, right? We're not meeting any of these, so there is no overflow. If you justify this, the accumulator content is 0 1 0 0, and the flag ratio is overflow 0. If there is overflow, we don't do anything, we just report the accumulator content 0 1 0 0, that is plus 4. So this is the answer. Let's see the next example. We have minus 7 plus 3, the result is minus 4. Here we can see the in and out carry is 0 0, that means there is no overflow. And we can also see that minus 4, we can represent minus 4 in here, so there is no overflow. Let's justify this. So we have accumulator here 1 1 0 0, there is no overflow, so we can just write the accumulator, and this is the result. Don't think that it is 8 plus 4 12. It is not 12, because 1100 is in 2's complement format. So if we need to find the value of 1100, due to this one we have negative sign, and if you convert this, this is 0, this is 0, the first one is 1, and everything after 1 is inverted, so you can say this is 4 only, so this is minus 4, right? Now the last example, minus 7 minus 3, we have minus 10, and here we have in carry as 0, out carry is as 1, so definitely there is overflow. In carry is 0, so negative overflow, and the result is 0, then also negative overflow. Like you can use any of this to find if there is positive or negative overflow, because we are going to solve get questions in the next video that will depend on these like overflow conditions. uh, let's justify this. So accumulator is 0 1 1 0, but here we have this overflow, and this is negative overflow because x by z bar is 1, z is 0. So what we will do, if there is negative overflow, we put 1 here, right? The accumulator content is this, and then we have put 1 here. So this is minus 10, because 1 0 1 1 0, if we try to find the value, we have this 0 with the first one 1, and everything is inverted here, so 0 1 0, this is nothing but 10, and the sign is negative. So this is how we like add these numbers into its complement, and how we can like find the overflow conditions using the in and out carry, or using the in this MSB bits of operands and result. So this is very important concepts. Try to understand and remember these things. In the next video, we will solve get questions on this. Thank you so much.